Assalamualaikum warahmatullahi wabarakatuh. Good morning everyone. My name is Nada from Group 1. Today we would like to explain our materials about correlations and regressions. In this video, we would like to discuss about the definitions of correlation in statistics, the definitions of regression in statistics, the differences between correlations and regression, calculations of correlation coefficient and regression analysis and linear regression, the fifth examples of one of the problem in correlation and regression, the last but not least, the conclusion. Well, without any further ado, let's move to the next part.
What is the correlation? Correlation is a term that is measure of the strength of a linear relationship between two quantitative variables. Example, height and weight. This post will define positive and negative correlation illustrated with example and explanation of how to measure correlation. Finally, some pitfalls regarding the use of correlation will be discussed. Positive correlation is a relationship between two variables in which both variables move in the same direction. This is when one variable increases while the other increases and vice versa. For example, positive correlation may be that the more you exercise, the more calories you will burn. Whilst negative correlation is a relationship where one variable increases as the other decreases and vice versa. Where it is possible to predict with a reasonably high level of accuracy the values of one variable based on the values of the other. The relationship between the two variables is described as a strong correlation. Weak correlation is one where on average the values of one variable are related to the other, but there are many expectations.
Regression is a statistical method used in finance, investing, and other disciplines that attempts to determine the strength and character of the relationship between one dependent variable, usually denoted by y, and a series of the other variables known as dependent variables. Regression helps investment and financial managers to follow assets and understand the relationship between variables, such as commodity price and the stock of businesses dealing in those commodities. The two basic types of regression are simple linear regression and multiple linear regression, although there are not linear regression methods for more complicated data and analysis. Simple linear regression uses an independent variable to explain or predict the outcomes of the dependent variable y, while multiple linear regression uses two or more independent variables to predict the outcomes. Regression can help finance and investment professionals as well as professionals in other businesses. Regression can also have predict sales for a company based on whether previous sales, GDP growth, or other types of condition. The capital assets pricing model (CAPM) is an often used regression model in finance for pricing assets and
My name is Azra and I'm from Group 1. I will explain the difference between correlation and regression analysis. Correlation means measure that defines relationship or association of two variables, and regression is how to describe independent variable is associated with the dependent variable. When we use correlation, no difference between dependent and independent variables. but for regression, both variables are indifferent. And then, correlation used to describe a linear relationship between two variables. And for regression is how to fit the baseline in estimate one variable based on another variable. The objective for correlation is how to find a value expression the relationship between variables. On the other hand, regression is how to estimate value of random variable based on the values of a fixed variables.
Hello everyone, my name is Zumaronafie and I will be your speaker for this topic. There are two topics in this section. The first one will be calculation of correlation coefficients, and the second one is regressions analysis and linear regressions. Let's have a look at the first topic. As you can see on the slide, there are 4 different scatter plots, which obviously have different meaning. What this diagram means is the quantity of the degree to which two variables are associated, when r is 0 and the relationship does not exist. When r is positive, when one variable goes high as the other goes up. When r is negative, one variable goes high as the other goes down. Other complicated measures are used if a curved line is needed to represent the relationship. And I hope these graphical representations could make you have a greater understanding. As shown on the slide, right on the top left, a positive variable means the result is increasing. And go to the right, you'll see the negative variable. It means the result is decreasing. And on the box C, you'll see a couple of dots. It means there is no relationship between variable, or we could say both variables are 0, so it has 0 relation. So from here, we could make a simple conclusion that you can use correlations for quick and simple summary of directions and strength of the relationship between two or more numeric. And now let's jump to the second material. On the other hand, regression is how one variable affects another, or changes in a variable that trigger changes in another. Essentially, it is a cause and effect. It implies that the outcome is dependent on one or more variables. As I mentioned before, we could check the strength of the relations between two variables with correlations. Now, with regressions, we could have predictions, or we'll be able to estimate the unknown variable to make future projections on events and goals. The main objective of regressions analysis itself is to estimate the values of a random variable based on the values of your known or the fixed variable. And linear regression is considered to be the best fitting line through the data points. So here is the perfect example that we found in order to make you understand the second point is easier. So as you can see on the left table, we have years and amount, and this in this case is inches. So let's make a story. Let's say global warming may reducing average snowfall in a town called A, and you're asked to predict how much snow you think it will fall on 2014. Look at the following table. You might guess will be 10 to 20 inches. That could be the good guess, but you could make a better guess by using regressions. And if we move to the side a little bit, we'll see the regressions line running down through the data. Now you can prove that the first guess is way too far. As shown on the data, it looks like the line will be somewhere between 5 to 10 inches. So we'll agree we could estimate or predict our data in the future using regressions in our analysis. And also it provides us more detailed look of our data, instead of just using correlations. So that's all from me. Time and place will be given to the next speaker. Thanks a lot.
The coefficient of correlation. A study was conducted to find whether there is any relationship between the weight and blood pressure of an individual. The following set of data was arrived at from a clinical study. Let us determine the coefficient of correlation for this set of data. The first column represents the serial number, and the second and third column represent the weight and blood pressure of each patient. Okay. The solution is correlation is n multiplied xy minus x multiplied divided square root of n multiplied x squared plus x multiplied 10 multiplied y squared minus y squared. The result of correlation is 0, comma example of regression equation. Scores made by students in statistics in the midterm and final examination are given here. A regression equation which may be used to predict final examination scores from the midterm score. Okay, there are 10 students and there are 10 and score. Predict the final exam scores. So let us decide y for the final exam scores and x for the midterm exam scores. We open the following table for the calculations. Okay, is 10,160. Denominator of B is 1000 and 985. Denominator is 0, 51 and 5, and denominator of A is 10. Therefore, A 40, 75 and given by y square is 40, 75 and 30 plus 51 and 27x. We can use for y squared is 66, which is estimation. Another example, the mid score is y score is 76, which is estimation.
Assalamualaikum warahmatullahi wabarakatuh. My name is Laras Maulida Sari, and I'm going to give the conclusion about our materials. So, the first is the definition of correlation and regression. The definition of correlation simply terms can be understood as a relationship. However, it cannot be extended only to that understanding until further established. Correlation is one of the empirical methods used in statistics to create a quantitative association between two variables. The association between these two variables may be due to a causal relationship, or it may also occur by chance. And then statistical regression analysis is a tool for evaluating the causal correlation between the variable. One of the most common and commonly used analyses is regression analysis for estimation and foreseeing. Regression analysis is widely used with complementary uses in the field of computer education. This study also helps to understand which independent variables are related and assess the types of relationship with dependent variable. And then how to use the scale. First is a scale nominal. It's an index scale or name just that has no meaning other than that. The second is scale ordinal. It's a classification scale where the given code gives the data a certain order but the variance is not equal and no absolute none. Nominal and ordinal scales are commonly evaluated using non-parametric statistics such as Kendall correlation, Spearman rank correlation, and chi-square and others. And the third is a scale of range, a measuring scale that has the same disparity but does not have an absolute zero value. While the variations are equal, they have no absolute null. The last is a scale ratio, the largest measuring scale with the same difference and not an absolute zero mean between any measurement. Measuring interval and ratio scales typically are subject to parametric statistical instruments. Okay, and then the differences between correlation and regression. First, regression establishes how x causes y to change, and the result will change if x and y are swapped. With correlation, x and y are variables that can be interchanged and get the same result. Second, correlation is a single statistic or data point, whereas regression is the entire equation with all the data points that are represented with a line. Correlation shows the relationship between the two variables, while regression allow us to see how one affects the others. And last, the data shown with regression establishes a cause and effect when one changes, so the other and not always in the same direction. With correlation, the variables move together.